Aloha students. Today we are going to be talking about the commutative property. And the commutative property says that you can move and reorder addends or factors in an expression. Now let's take a look at the root word of commutative, which is commute. It sounds like compute. It looks like compute, but the fourth letter is a P instead of an M. And while compute means to calculate or figure things out mathematically, commute means to move from one place to another. For example, workers commute to their jobs by driving a car, taking the bus, or even walking. Now, the commutative property is known as the order property because you can change the order of addends or factors in an expression. But I like to think of it as the moving property because you can move addends or factors in an expression. Let's take a look at how it works. If we express 4 plus 2 a different way, it is still equal to 6. 4 strawberries and 2 pineapples is the same thing as 2 pineapples and 4 strawberries. But how can that help us? Let's look at this expression, 7 plus 5 plus 3. Now, right off my head, I can't recall what 7 plus 5 is, but I know for sure that 7 plus 3 is 10, and I can add from there. The commutative property of addition says that you can change the order of the addends and still get the same sum. But does it work for subtraction? Let's try it and see. The best way to explain why the commutative property doesn't work for subtraction is to use a number line. If we take the expression 4 minus 2, we start with a total of 4 and subtract 2. Our subtrahend is 4. If we flip that around to 2 minus 4, now we're starting with 2 as our subtrahend. And we're taking away 4, so we're way down in the negative numbers. 2 does not equal negative 2. So we can say that the commutative property does not work for subtraction. Now, the commutative property also works for multiplication. We can have 4 groups of 2, or we can have 2 groups of 4. 4 times 2 is 8, and 2 times 4 is 8. So there is a commutative property of multiplication where you can change the order of the factors and still get the same product. So how can the commutative property of multiplication help us? Well, let's look at this equation. 4 times 6 times 5 is exactly the same thing as 4 times 6 times 5. But I hate to admit it, but I cannot recall my 4 times 6 fact for the life of me. And what I'm going to do is I know that 4 times 5 is 20. And if it has a 2 in the tens place, I can just do a doubling. 20 times 6, put my 0 into the product. I'm left with 6 times 2, which is 12. Our total is 120. I suppose I could have done it the other way, where I multiplied 6 times 5 to get 30, and then multiplied that by 4. But I would need parentheses to show that that operation would go first in the expression. Move my 0 to the product, and 4 times 3 is 12. So we have a total of 120. According to the commutative property of multiplication, you can change the order of the factors and still get the same product. But does it work for division? Let's try a problem and check it out. In the first expression, we're starting out with 4 boxes. In the second expression, we're starting out with 2. Now it's easy to divide 4 into half, into 2 parts. But dividing 2 wholes into 4 separate parts, I'm going to end up with a fraction. And each one of those parts is worth a half. Looking at this as a fraction, we can see the dividing line, which represents division, that separates the numerator from the denominator. And what we've done is we've divided 2 into 4 parts. We could also look at this as 2/4. In both situations, we get 1/2. Well, 2/4 may be equal to 1/2, but it is not equal to 2. So the answer to the expression 4 divided by 2 is not equal to the expression 2 divided by 4. So we can see that the commutative property does not work for division. According to the commutative property of addition, you can change the order of the addends and still get the same sum. According to the commutative property of multiplication, you can change the order of the factors and still get the same product. I hope this helps. Ahui ho!